Hey, it's Imran. Welcome to the demonstration video of ResEval Mash. It is a mashup tool for doing research impact evaluation. Before showing you the tool, let's have a brief introduction of the research evaluation. Research evaluation is the assessment of the productivity or quality of researchers, research groups, institutions, journals, and so on. Why research evaluation is needed? As the research landscape evolves, assessing the impact of researchers and publication is in high demand for a variety of reasons, such as funds distribution, faculty hiring and promotions, giving awards to experts, as well as to support the search for interesting contents. In our opinion, there are a number of different ingredients used for this purpose. For example, there are different units which can be evaluated, like artifacts, individuals, groups, and so on. There are different sources available, like Google Scholar, Springer, DBLP, and there are many others. One can use different indices for assessment, such as H-index, G-index, AR-index. Different complex evaluation criteria can be used. For instance, to check the diversity or autonomy of a researcher, applying different filtering criteria. And there are many other depending on the situations. As we have seen the diversity in all these ingredients, and there are no commonly accepted criteria for the research evaluation. So we thought to let users to model their trivial as well as non-trivial research evaluation procedures by their own. One of these complex evaluation procedures that I am going to show you in this video is to evaluate researchers of the Department of Information Engineering and Computer Science at University of Toronto. DC administration periodically checks the productivity of the researchers working in the department using complex evaluation procedure, which is the following. The scenario has a number of steps. First of all, a list of all Italian researchers belonging to the same disciplinary sector of DC is retrieved from a national registry. Publications for each researcher of DC and for the researchers selected during step 1 are extracted from an aggregate data source. The publications obtained in the previous step are then weighted using a Venn classification. In step 4, a negative binomial distribution of the weighted publications count is then computed for all the researchers. As a last step, each DC researcher is ranked based on his individual weighted publication count over the computed statistical distribution during step 4, thereby estimating his percentile. Okay, now I am going to show you the composition editor. On the right hand side, there is a list of available components under different categories. Just click on a category to open or close it. On mouse hover, a component shows its description with possible input, output and configuration parameter details. On bottom right side, composition name and its description can be provided along with its visibility status like public or private. A user can run, save and close a composition using top menu buttons. There are also editor shows some useful tips. Okay, let's have a look at a component. A user can easily drag drop a component from the list to the canvas. On the left side of this component, it shows input ports, and on the right side, it shows output ports. On mouse over, it shows what a port accepts. There could be few configuration parameters which can be set. A user can change the component name by clicking on its name label. Double-click on a component to close or open its configuration panel. Let's put another component to see how to make connection between components. When a user clicks an output port, the other components start highlighting their input ports if they are compatible. Compatible means what a source component port produces is acceptable by the target component ports. Let's make the composition of DC evaluation scenario, which I have described earlier. For this purpose, I need to have DC researchers and other Italian researchers, which is very easy to do with the Italian researcher component. So let's drag drop this component. My composition is ready to run. Before running this composition, I'm gonna tell you that there are few components which will process large amount of data. For instance, Italian researcher component is going to get all the Italian researchers in all universities of Italy. And then Microsoft Academic component will retrieve all the publications of all the researchers. So for this purpose, the tool shows to the user the status of each component while running. Like, is it still processing, or execution done, or in case of execution failure. Before running the composition, notice that the text color of the names of the components are black, while after successful execution it turns into green color. Okay, let's run it. To see the results, let's click on the small monitor icon on UIE component. So here is the pie chart of the results. Okay, let me explain a few technical details which make ResEval Mash unique. So first of all, we use domain terminologies and syntax a domain expert is familiar with. Thus, understanding a component and its functionalities become very intuitive for a domain expert. Another important aspect of this tool is that it doesn't require complex data mappings. And we achieve this with having a common concept model, which is used by all the components. What a component produces or accepts is a domain concept, that's it. So to make connection tasks easier for a user. Last but not the least, the tool also supports the processing of large amounts of data, a feature that is achieved via the sensible distribution of the respective computation steps over client and server sides. The compositions executes at client side, and as most of the components are binded with their respective services, so each service takes data from a shared memory, which is at server side, processes it, and stores it to the shared memory again. Only a control signal is passed to the respective component, which is then passed to other components to start processing. We have conducted the interviews of 10 domain experts. Among them, 5 are IT skilled and 5 non-IT skilled. The purpose of this study was to check mainly the user preference in generic versus domain-specific tools. We showed to the user Yahoo Pipes as a generic mashup tool in comparison with our ResEval Mash tool, which is a domain-specific one. The second purpose was to check the usability of ResEval Mash. What we have got from these user studies is that 90% of the users preferred ResEval Mash over Yahoo Pipes, and the users found ResEval Mash offers the right balance between flexibility and complexity. That's it for now. For more details, visit open.reseval.org website. Thank you.